Hello and welcome to Genesis Training. This is your trainer Kaustav. In this video, we'll be dealing with time and work, and the subtopic we'll be dealing with is called pipes and cisterns. Let's get started with the concepts first. Now, a lot of people tell that they are good with time and work, but they are bad at pipes and cisterns. But let me tell you, that is absolutely impossible to happen. Because when it comes to time and work, we deal with human beings doing some work. And when we deal with pipes and cisterns, we deal with pipes or taps doing some work. Okay. In time and work, we focus on the people doing some kind of work. In pipes and cisterns, the work is just filling a tank. That's it. Filling a tank or a cistern. That is the entire work that is being done. So pipes or taps filling a tank or a cistern. That's it. That is all that there is. The only slightly new concept in pipes and cisterns is the negative work done. That happens when there are leaks. Okay. What does negative work mean? That means whatever somebody else is doing, like suppose you can write 5 pages in 1 hour, but I can erase 2 pages in 1 hour. That is negative work being done. That means whatever positive work is being done, the opposite of that. That is what happens in leak. So let's start solving the questions and we'll see how this negative work also gets into the situation. Question number 1. Two pipes can fill the cistern in 10 hours and 12 hours respectively, while the third empties it in 20 hours. If all the pipes are open simultaneously, then the cistern will be filled in how many hours? Okay. So first we'll write the efficiencies of each pipe. So efficiency of pipe 1 equals 1 by 10, because work done is one full cistern being full and time taken is 10 hours. So 1 by 10. Efficiency of pipe 2 equals 1 by 12, because it can fill the entire tank, the cistern, in 12 hours. While the third empties it, so efficiency of pipe 3 empties it. So filling the entire tank, work done is plus 1, emptying the entire tank, work done is minus 1 by 20. Okay, so when all of them are opened simultaneously, that means all of them are working. That means the combined efficiency will be efficiency of pipe 1 plus efficiency of pipe 2 plus efficiency of pipe 3. That is nothing but 1 by 10 plus 1 by 12 minus 1 by 20. The LCM of these is 60. 60 by 10 is 5 plus 60 by 12 is 60 by 10 is 6. 60 by 12 is 5. 60 by 20 is 3. So we have 8 by 60. This is the combined efficiency of all of them. Now if at all they ask the time taken to fill the entire tank, that will obviously be the reciprocal of this. So time taken is 60 by 8. That is nothing but 7.5 hours. I'll tell you a mathematical trick to divide by 8. Now, if you do 60 divided by 8, it becomes a little tougher. But if at all you divide and conquer, don't consider 8 as an entire number. Take it as 3 2s, 2 into 2 into 2. So whenever you have to divide a number by 8, you divide it by 2 thrice. For example, let's see how easy it is. 60 by 2 is 30, 30 by 2 is 15, 15 by 2 is 7.5. That one is much easier to do than 60 by 8. That is why keep the numbers small. It will always help you do mental calculations. So the answer is D, 7.5 hours. Let's move on. A cistern is normally filled in 5 hours. Let's imagine that there is a pipe filling the cistern. So efficiency of the pipe is 1 by 5. However, it takes 6 hours when there is a leak in its bottom. So we have efficiency of pipe plus efficiency of the leak equals 1 by 6. It takes more time because the leak is also working, does negative work. So let's find the efficiency of the leak first of all, just the leak alone. That will be nothing but 1 by 6 minus 1 by 5, because this goes over there. This when you solve, you'll get minus 1 by 30. What does this mean? This means that the leak can empty the entire tank in 30 hours flat. So a lot of people mark C as the answer, but this is the wrong answer. Why? Because the question says if the cistern is full, in what time can the leak empty half of it? Half of it. You have to be very careful about that. So if the leak could empty the entire tank in 30 hours, then for half of it, the answer should be 30 by 2, that is 15. Answer is D. Moral of the story, before you mark the answer, make sure you read the last part of the question just once more. Let's move on. Question number 3. If two taps are running continuously to fill a tank, the first tap could fill it in 5 hours by itself, second one 20 hours, but the operator failed to realize that there was a leak in the tank from the beginning, which caused a delay of 1 hour. Okay, let's see without the leak how long it would take to fill the tank. We have efficiency of pipe 1, 1 by 5. Efficiency of pipe 2 is 1 by 20. When both of them are working together, it will take 1 by 5 plus 1 by 20. LCM is 20. 20 by 5 is 4. 20 is 1. So 5 by 20, that is 1 by 4. So without the leak, the tank would have been filled in 4 hours flat. But because there is a leak, there is a delay of 1 hour. That means the entire time taken when the pipe 1 is working, the pipe 2 is also working, and the leak is also working, there's a delay of 1 hour. So it takes 1 by 4 plus 1. It takes 5 hours to fill the entire tank. This is 1 by 5. Let's do this. Efficiency of pipe 1 is 1 by 5 plus pipe 2 is 1 by 20 plus efficiency of the leak equals 1 by 5. So 1 by 5 and 1 by 5 gone. That means efficiency of the leak is minus 1 by 20. So the leak can empty the entire tank in 20 hours. Let's see if that is the question. Find the time in which the leak would empty a filled tank. Yes, so the answer is 20 hours. Done. Keep a habit of reading the question in the end also. Question number 4. Two pipes can fill a tank in 20 hours, 24 hours respectively, and a waste pipe can empty 3 gallons per minute. Okay. All the 3 pipes working together can fill the tank in 15 minutes. The capacity of the tank is what we need to find. Okay. So efficiency of pipe 1 is 1 by 20. Efficiency of pipe 2 is 1 by 24. And efficiency of pipe 1 plus efficiency of pipe 2 plus efficiency of the waste pipe equals 1 by 15, because it takes 15 minutes when everything is active. So efficiency of the waste pipe is 1 by 15 minus 1 by 20 minus 1 by 24. This is equal to, the LCM is 120. 120 by 15 is 8 minus 120 by 20 is 6 minus 120 by 24 is 5. Okay, so this is equal to how much? 8 minus 6 is 2. 2 minus 5 is minus 3 by 120. That is nothing but minus 1 by 40. This means that the waste pipe can empty the entire tank in 40 minutes. And they have told that the waste pipe can empty 3 gallons per minute. 3 gallons per minute. So 3 gallons per minute for 40 minutes. That is the entire capacity of the tank. So the capacity is 40 minutes into 3 gallons per minute. That is 120 gallons. Answer is C. Alright, let's move on. Question number 5. 3 taps P, Q and R can fill a tank in 12, 15, 20 hours respectively. If P is open all the time, Q and R are open for 1 hour each alternately, starting with Q. Then the tank will be full in how many hours? Okay. In such questions, there is a special way to do this. So work done in the first hour. Who all are working in the first hour? P is working all the time and Q is working. R is not working in the first hour. So this is nothing but 1 by 12 plus 1 by 15. LCM is 60. We have 5 plus 4. That is 9 by 60. Keep it as 9 by 60 itself. Don't need to reduce this. Now let's find the work done in the second hour. In the second hour, P is working and R is working. So this is 1 by 12 plus R's efficiency is 1 by 20. Again the LCM is 60. 60 by 12 is 5. 60 by 20 is 3. That is 8 by 60. Do not reduce this also. See, the thing is, same denominator is always a blessing. Remember that. So keep the denominator same as much as possible. So let's find the work done in 2 hours. That is first hour plus second hour. That is 9 by 60 plus 8 by 60. That is equal to 17 by 60. This is work done in 2 hours. Okay. Now, over here, the smallest option is 7 hours. I'm telling you how to reduce your time. That means we have to at least go till 7 hours. So let's find the work done in 2 hours. We already know. So what will be the work done in 6 hours? Work done in 6 hours will be 17 by 60 into 3. Because 2 hours this much, 6 hours will be this much into 3. That is nothing but 51 by 60. Let's find the work done in 8 hours now. Work done in 8 hours will be 17 by 60 into 4. Because 2 hours is this, 8 hours will be this into 4. That is equal to 68 by 60. But this is greater than 1. This is not possible. You cannot do work which is greater than 1 because the maximum work that you can do is always 1. So 8 hours is too much and 6 hours is less than 1. So that is too less. So the answer has to be between 6 hours and 8 hours. And luckily we have an option which says 7 hours. So that will be the answer. You don't need to solve it further. By elimination method, you get the correct answer. That's it. Answer is B. If at all you want to verify this, you can verify this also. What will be the work done in 7 hours? That is nothing but, first of all, the work done in 6 hours, that is 51 by 60 plus the 7th hour is this one, work done in the first hour, that is the work done in the 3rd hour, 5th hour and 7th hour, that is 9 by 60. So 9 by 60. This is equal to 60 by 60 and that is equal to 1. Hence proved in 7 hours, exact one full work is being done. That is all for this video. Thank you so much.